Our objective in this lesson is to be able to verify characteristics of parallelograms and use properties of parallelograms to solve problems. Let's remind ourselves what is a quadrilateral, that is any four-sided polygon, and what is a parallelogram? Like the word has it, parallel in it, that is a quadrilateral that has the following special properties. Parallel sides is the first one that we think of. Both pairs of opposite sides are parallel. So we have the arrows that indicate that these sides are parallel and arrows that indicate these sides are parallel. Similarly, we have both pairs of opposite sides that are congruent. Notice the difference between those marks and those marks. Whereas these are parallel arrows, these are congruent hash marks to show that this length is the same as this length and this length is the same as this length, or the opposite sides are congruent. Also, one pair of opposite sides, so if we just know about one pair of opposite sides, they have to be both parallel and congruent. Notice the parallel arrows and the congruent hash marks on the one pair of sides. Also, both pairs of opposite angles are congruent. This angle and across from it, this angle are congruent, and this angle and across from it, this angle are congruent. Also, consecutive angles, those are the angles next to each other, are supplementary. So see how this angle that is obtuse, perhaps it's 100 degrees, and this angle that's acute, perhaps it's 80 degrees. Those must add up to 180 degrees. Any consecutive angles, these angles, consecutive, meaning next to each other, have to add up to 180 degrees, have to be supplementary. And one more, that the diagonals bisect each other. So notice that the diagonals are intersecting, but they are cutting each other in half. That is congruent to that, and on the other diagonal, that half congruent to that half. So there's your refresher on the parallelogram. Now we've got special types of parallelograms, and the first one we're going to look at is the rhombus. A rhombus is a parallelogram that has the following properties. So of course, because it's a parallelogram, it has everything that we previously mentioned, but also it has all four sides congruent. Notice the congruent marks to show that all four sides are the same length. That's what makes it a rhombus. Whereas in a parallelogram, it's merely the opposite sides that are congruent, not necessarily all four. In a rhombus, it's all four sides are congruent. In a rhombus, the diagonals are perpendicular. That means they make a 90-degree angle where they intersect each other. Remember that when we work with perpendicular lines, that we know the relationships between the slopes of the lines. So the diagonals are perpendicular can also tell us about the slopes of those diagonals, that the slopes are opposite reciprocals of each other. We'll look at what that means when we see an example. Now, when we think of parallel, like in the parallelogram, where the opposite sides are parallel, if we think of those slopes, we want to remember that that means slopes are the same. So parallel sides have the same slope. Perpendicular segments have opposite reciprocal slopes. Finally, in the rhombus, diagonals bisect opposite angles. Of course, because it's a parallelogram, diagonals do bisect each other, but they also bisect the opposite angles. That's what is shown here, how not only are these opposite angles congruent, but that angle is congruent to the one next to it because it's been bisected, and that angle is congruent to the one next to it. And similarly, this diagonal is bisecting the angle, so that angle is congruent to the one next to it, and that angle is congruent to the one next to it. The diagonals are bisected. Let's look at some examples. The diagonals of rhombus WXYZ intersect at point V. So the Rhombus is important that we know that because it has then all of these properties that we just discussed. Given that the measure of angle xzy equals 34 degrees, that's important to note. Let's make sure it's in our picture. X, Z, Y is 34 degrees. Okay, it's shown. And WV equals 7. WV is 7. That's shown too. Find the indicated measure. If we know it's a rhombus, first I might want to mark all the things that I know about a rhombus, like the diagonals are perpendicular. Now also because it's a parallelogram, not only are the diagonals perpendicular, which means I can put this right angle here, but the diagonals also have to bisect each other. So that is congruent to that, and this half of the other diagonal is congruent to that half of the diagonal. In terms of the fact that it's a rhombus, all four sides have to be congruent. So these four sides will all have the same measure. Let's put a different hash mark than what we've seen already. Also, because it's a rhombus, the diagonals bisect the opposite angles. So if we know that this angle is 34 degrees, the one next to it has to be congruent, and the ones opposite must also be congruent because of the fact that it's a parallelogram. Let's see now how we can answer the questions. Measure of angle WZV equals, so where is WZV? Now because we smartly marked our picture, we can easily tell how much WZV measures because we already wrote it in. It is 34 degrees. ZY. ZY is this side right here. Now, if I knew what another side was, it would have to be the same, but I don't. So we're going to have to get a little bit creative here. So I know that this is a right angle up here, therefore this is a right angle vertical to it. In fact, all four of these are right angles. Notice that we have a triangle here, and because of the right angle, it is a right triangle. I'm going to draw this triangle separate from the picture to help us out. I'm going to keep it in the same orientation and mark everything that's marked in this picture. Z, V, and Y are the three vertices. There's that right angle that I noted because it's a rhombus, and this angle is 34 degrees. I know that because the diagonals have bisected each other, that if this length is 7, this length is 7, so I can mark that in my triangle as well. What we're looking for is ZY, that length. I'm going to put a question mark there because that's the side in question. So therefore, in this picture, I'm going to put a question mark here. That's the side I'm looking for. How do we find a missing side of a right triangle given an angle measure and a side length? That's right. We have to use SOHCAHTOA. Let's write that down. SOHCAHTOA. From our angle, let's label the sides opposite, and from the right angle, the hypotenuse, and the adjacent doesn't have anything on it, so we'll leave that out. So now you can see that because we need the hypotenuse and we're given the opposite side, we'll be using sine. Let's make an equation then that uses sine. Sine of our angle, 34 degrees, equals opposite over hypotenuse, which is 7 over the question mark side. To solve for that question mark side, I switch these places and will divide. 7 divided by sine of 34 degrees. Using my calculator, I get approximately 12.5. And there we have it. ZY is 12.5. Approximately, of course. Let's talk about slope now. If the slope of WY, segment WY, is negative 1/2, then the slope of segment ZX is what? Well, WY is this diagonal right here, and ZX, here let's highlight that, WY is this diagonal, that has a slope of negative 1/2, and segment ZX is this diagonal. They are intersecting each other at a right angle, so they are perpendicular. So the slopes have to be opposite reciprocals. Remember what that means is opposite sign, so positive instead of negative, and flipped over, so 2 over 1 instead of 1 over 2. Now, we usually don't write it this way. The simpler way to write it is just 2. Let's look at another pair of sides. If the slope of segment WZ, let's highlight that in a new color. WZ is 5/3. WZ is this side. Then the slope of XY, well, where is XY? An opposite side. Opposite sides are parallel. Notice they're going in the same direction. Therefore, they must have the same slope, or in this case, 5/3. Thanks for watching.